Hi everyone, welcome back to the channel and this new video. Recently I obtained this key machine as a secondary machine to the existing one we already have. The reason being is because this fixture is broken on this first machine, which doesn't allow you to swap from the A carriage to the B carriage. The problem being is when we receive this second-hand machine, it doesn't have a blade guard. As you can see from this original machine, this blade guard screws onto there, covers the blade when you cut in the keys, etc. This machine came with like a temporary guard that someone had manufactured out of just a bit of flexible plastic, which was not really up to the job. So in this video I thought we could go about creating a similar guard to this for this machine. Now luckily in this example we've got an item to copy straight off the bat. As you can see, this unscrews at these 2 points here and the blade guard simply slides off, and obviously because this is a similar machine, this slides onto there the same. So the idea is to reproduce some kind of guard that will go on this machine to obviously protect my eyes when I'm cutting a customer's key. A little bit of background about the machine. This is an RST Mortice machine. It is an American company. Again, with us being in the UK, you know, these kind of things are quite difficult to source. We'd have to find a supplier in the USA, import it, etc. By the time you do that, it becomes very costly indeed, just for this small piece of plastic. And a bit of background about me in general. We do own a key cutters and DIY shop here, so as you can see, if you just pan round, you can see the vast array of keys that we cut on a daily basis. So these machines are in constant use, so it's something could really do with getting fixed. So what we'll do is we'll jump on a piece of paper, get some measurements, then into CAD, create a design, and see if we can 3D print this. So let's go about taking some measurements for this guard. I've got the guard, got some calipers to sharpen my pencil, so we should be ready to go. Now you think to yourself, first thing we do, let's draw a sketch. Not this time. First thing I'm going to do is to actually trace around this object. Now other people are going to have other methods of doing this. You know, you could take a photograph and then drop that into CAD, etc, etc. What I'm going to do is I'm going to take this traced image and I'm going to put it onto a flatbed scanner. Now the reason to do this is because when you take a photograph of something, it tends to get a little bit distorted by the camera angles. Whereas if you've got the physical object, you then trace the object. If you put this onto a flatbed scanner and then into CAD and calibrate the dimensions, etc., then you'll get hopefully a pretty accurate representation of what you're trying to copy. So that's what you would say the base plan of this item. Now there's a couple of measurements we do need. One being the height of the guard, which in this case we'll call it 65 millimeters. So I'll just write height 65 millimeters. I apologise if, you know, obviously some USA viewers, etc., you may obviously prefer that in inches to 2.559 inches. Apologies that I can't do all the video in inches because I've got my CAD set up into millimeters because that's what we predominantly deal with here in the UK. The other measurement we need is the thickness. So in this case, we'll go 3.3 millimeters there. Just convert to that to inches, 0.132 inches. The other measurement we could do with is the overall height of this, where the screw hole's going to, which in this case I just revert it back to millimeters, 11.85. So that's as cut out 11.85 millimeters. In inches, that's 0.465. And just for clarity on this drawing, I'll just take that bottom measurement. Just again, convert to millimeters, 4.89. Which is 0.187 of an inch. So there should be the basic measurements we need. Obviously, I've got to take into account these curves, etc. I'll show you how I handle the shape of the bottom, or how I would handle it in the best way. So, as you can see, even this one's got a small crack in it. This is quite an old one, so it has had a lot of use over the time. You may be thinking, oh, does it need to be in clear plastic? In an ideal situation, yes, but to be honest, where it's located, this covers the blade, and when you're actually cutting a key, you're not actually looking at the blade, you're looking at the guide. So in general, you don't tend to look directly where the blade's cutting on a glance, and you can see underneath. Obviously, this guard protects chips from flying and getting in your eyes, etc. So it's quite a much needed safety aspect. So what I'll do is I'll put this into the scanner, get a PDF, and then we'll take the PDF and we'll import it into Fusion, and then see if we can replicate this card. One thing I did just forget to do and mention is I've got a steel rule here. So I've got a pen this time just because it's a bit finer point on it. So not the greatest pen, if you can see. That's what I have to deal with in the UK. Cheapy creepy pens that break instantly. Anyway, moving on. So I've marked the end of the ruler. I'm just going to mark at 50 mils. I'll mark 50 mils on this piece of paper. So we know the measurement between there is 50 mils. So when we go into CAD, once we scan that and then we go into CAD, we'll use that 50 mils to calibrate the image to get the size correct. So here we are again in Autodesk Fusion. Like in previous videos, the first thing I'm going to do is save the file. In this case, we'll name it RST Blade Guard. So always prudent to save the file first thing, and then hopefully it will auto save as you're going through, and obviously try and remember to keep saving so you don't lose any of your work, just in case. So I exported a PDF file that I obtained from the scanner, and actually I realised that I shouldn't have exported it as a PDF because it doesn't import into Fusion as a PDF, so I had to re-export it as a JPEG. So I personally have an Adobe Cloud subscription, so I have access to Adobe Acrobat, etc., and other photo editing software and all things like that, which you may or may not have. But I scanned the document into Adobe Acrobat and then exported that as a JPEG, so I can then import into Fusion 360. So that's what I'm going to do. I'm going to go to the Insert tab, scroll down to Canvas, click on it, find the file which I exported. In this case, it's RST. Click Open. Now you need to select the face that you want to put the canvas down onto. So I'm going to select the horizontal plane. Click OK with that. So go down to a top-down approach, so zoom in a little bit. You can see the scanned image. Oops, in front of me there. So the next thing I want to do is to calibrate the image. So to do that, go and find your image under canvases in the left-hand tree menu, and right-click and click Calibrate. Basically, what this does, it asks you to pinpoint 2 points and the distance between. So I'm going to select this point that we put on the scanned image, and this point here, so we know the distance between these two is 50 millimeters. So if I type in 50 millimeters, press enter, just fit it to the window. You can see now this drawing is going to be dimensionally accurate. So if we click measure, I don't know if it's going to allow me to do between, no, it won't allow me to do between 2 points there. If we were to click measure, that would measure 50 millimeters. So the next thing I'm going to do, I'm going to create a sketch, and I'm going to create it on this plane again. So I'll just show you with if we press L for line, if I click that point and drag it out, you can see that's 50 millimeters almost. So I'll just escape out of that. Now this is slightly tricky to work out how you would approach this. Now I'm going to go to create a circle, and I'm going to select a 3-point circle. So I'm going to click the inside left corner of this scanned image and the right hand side corner. And what it does, it allows me to drag it out. So I'm going to drag it so that this circle then finds the correct curve of this scanned image. Now the reason I'm doing this is not to use this as a line for the final model. It's basically to get the center of this arc. Because in terms of this scanned image, this portion of this drawing is going to be a little bit greater because obviously we've traced around the object with a pencil, etc. So we'll have to take that into account. So what I'm going to do, I'm going to create a new circle now from this center point, and I'm going to drag it out. I'm going to select what I would envisage the center of those pencil marks. And then what I'm going to do, I'm going to actually delete the other circle. So select it, press delete, just to get rid of that circle now. Right, so I'm just going to quickly save this. So the next thing I'm going to do, I'm going to go to modify, change parameters, and I'm going to set some user parameters now. So the first is going to be height, 65 millimeters. Second is going to be thickness, 3.3 millimeters. Next is, we'll call it cutout height, 11.85 millimeters. And finally, cutout width at 4.89 millimeters. Just make sure you click OK on here. So what I'm going to do now to get this measurement here, to get these two curves here, I'm going to use this offset command. So I'm going to click the line, click offset. As you can see on this menu, it allows you to pick two sides. So the distance, we know the thickness is 3.3, but we actually want to divide that by 2 because we're going on the other side. So if select divide by 2 in the thickness, click OK. As you can see, we've now got two lines the correct distance apart on the right curvature of our sketch. So the next thing I'm going to do is try to account for these holes and also the edges of the part itself. So I'm going to create a new line. I'm going to go from the center here. I'm going to drag it to the point which is closest to that we've chosen on the sketch. And also on this side, drag another one here. Another one there. Another one here. And another one here. So what I want to do next is make sure that these two cutouts to my dimension is the same. Now, in Fusion, it only allows you to set the dimension as an angle between two lines that are not parallel. So in this instance, I'm just going to kind of eyeball this dimension. So I'm going to go create sketch dimension, click the two lines, drag it up, see that's set at 5.7 degrees. Or we'll actually put 5.7 there. So I want to make sure that this one is the same, so when we go to do some of the features, they're both set to the same distance. The next thing I want to do is go and trim some of this off now. So I'm going to select the trim tool. I'm going to go in. I'm going to trim all these lines off now that we don't need. So take out the center line. On these now. And also take out these lines here. Just so it tidies it up a bit. And the next thing I'm going to do, I'm going to turn this canvas off now. So as you can see the basic shape of a guard now. So now we've got rid of the canvas, I'm going to click Finish Sketch. Then go back into the 3D window. So now I'm going to click the Extrude command. I'm going to select all the elements for the time being. I'm going to click Height. So that will give us the height of the guard. Just going to revolve this now. So we get to the underside. Select Extrude again. Sorry, I made an error there. I'm going to go to Extrude. Height. Click OK. Turn that sketch back on. Revolve this round. Press Extrude again. And select these two. Elements. It's not letting me do that now, so that means we've got an error somewhere. So, well, as you can see, I'm doing this. I'm trying to do this all in one take, so you'll have to take my errors along with it. So I'm going to go back into the sketch. Double click on the sketch again. think, as you can see, that's trimmed too short. So go to modify, extend, click on that. Just extends that line to this point. I don't know why I did that, but we'll click finish sketch. Go back into a 3D view, rotate round, press extrude, select these two now. I'm going to create a cutout, but I'm going to set it as cutout height. So as you can see, if we go back to the normal view now, this guard is starting to take shape. As so. So what I'm going to do next, really it'd be nice to have these curved, especially for when it comes to printing, so that we don't have any need for supports under here. So we'll click on fillet, zoom in to these corners there. Because it's on an angle, it won't perform a perfect arc, because these two lines are on a slight angle to each other. So if we pull it as close as we can, call it 1.7, and click OK, and then we can go to the other one and make sure that is set at that same dimension. Let's go to modify, fillet, pull it out to 1.77, and there you have it. So that's, most of the guard now done. So to smooth this off now, I'm going to fillet these edges. I'm going to select the top edge, these two side edges. Just going to drag it in slowly. Let's get it to marry up. Let's change that to 1.43, see if that does it. Keep going up until you get to its almost its limit. Probably old hair with this, but try 6.0. Yeah, we'll leave it at that because it's almost a perfect curve. Click OK with that. I'm just going to see if it allows us to fillet these two edges. It doesn't always allow you to do it depending on what you've got. Well, it just let me do it now. So I'm just going to drag these in, set it at 10 millimeters. So that gives a nice curve on these two edges. You do have to be very careful the order that you do these fillets in, because it doesn't always allow you to do certain operations. So there you have it. That should be a good representation of the guard that we need. Obviously the only way is to try it and test it. So I'll just save this. I'm going to go to File, export, select STL. Just going to change the location. Click save. Oh, should I say click export? And there we have it. We'll jump into Bambu Studio next and get this ready for printing. So here we are in Bambu Studio. Going to create a new project. Change the device to one we've got. Sync the filaments. We've got some Bambu PLA Basics set in there. So I'm going to find the model. So there it is. Now, because we want to do a test print first, I'm actually going to cut the model. There's no point printing it all out when you're not entirely sure as to whether it's going to fit or not. So I'm just going to press cut. Find the Let's reset that. Did that wrong then. Reset again. I just want to drag it down the cut line just above the two slots so we know whether it's going to fit or not. Select perform cut, so then that produces two parts on the bed. So I'm going to select this one and just delete that for the time being. Drag this bar into the middle. And I'm just going to change a few settings. Change the wall loops to 3 to give it a bit more strength. And it's set to 2mm standard, which I think is good enough for this. So I'm just going to click slice. As you can see, it's going to take 19 minutes, 48 seconds. And one other thing, just need to go back into the, change that to gyro. I just prefer that setting on the infill. So as you can see, it'll start at the bottom layer, work its way up gradually, etc, etc. The other thing I just forgot to do, just go back into the settings again. Just go to the seam, we'll change that to back. That tends to give a nice uniform line somewhere on the print. In this case, it's just on that top edge there. That's probably because we've got these set to 2 curves. So I'm going to send this to the printer now. I'm not going to print it tonight because it's getting quite late. So I'm going to send it to the printer now and then reconvene in the morning and set it going on the printer. So I've got the printer selected, and we'll send that up to the printer ready for printing in the morning. So I've set the print going. It should only take about 19 minutes altogether. As you can see, again, printing very nicely on this machine. Just put a small addition to the machine there. For some reason, I don't know if any other people find the same problem, but this always gets trapped behind this stand here. Don't know why it's designed like that, but just printed this off Makerworld to try and prevent that happening. So we'll come back when it's finished. So the test print is now finished. So we'll get this off the bed and go test it on the machine. So I've just come to do a test fit of the part, and it appears the screw holes are just a little bit too tight for these. It's not allowing me to get the other nut in, and I think it's just because the gap here is just too tight, so it's not allowing enough flexibility in getting it in the exact correct position. So I'll make some alterations in CAD and increase this distance and see if we get a better result. So I've reprinted the design off camera. I haven't showed the CAD for this particular section, just so the video doesn't get too long, and also I was just running out of time to get this printed by the end of the day. So the alterations I've made, I've increased the hole size on each of these cutouts, and I've also just printed the whole thing out this time just to save a little bit of time. As I say, I was running out of time towards the end of the day, so we'll take this to the machine and hope this fits. So here we are at the machine again. Give it a try now and hope it fits, fingers crossed. Yeah, it's just a fraction tight on there, but you know, once it's tight, it'll definitely do the job, as you can see. Just got these two on the table so you can see a like-for-like comparison. The original guard versus 3D printed guard. It's a good example to show you how quick and easy it is to replicate a part, and obviously save yourself quite a bit of money. To get these imported could cost upwards of $20 or more, or £20 upwards, whereas this costs approximately $1, £1 here in the UK. And obviously a huge benefit is the time saving. Within maybe half an hour to design, an hour to print, we've got a finished product that we can use instead of waiting around for 2 or 3 weeks for one to be delivered. So thanks again for watching the video. I hope you found some of it useful and you can take away some little bits of information that you may find useful in your projects going forward. I'd also like to take this opportunity to thank those that commented in the previous videos. It does help to receive the feedback. I didn't really think I was going to receive any, so thank you very much for that. If you did enjoy the video, please like and subscribe to be notified of subsequent videos. So once again, thank you for watching, and I'll see you in the next video.